Electricity is an incredible tool. It literally powers our entire world. But here's the thing, it's also a completely invisible force, and it carries a massive amount of risk. So, how do you manage a danger you can't see or hear or even smell until it's way too late? Well, that's exactly why things like the Panaust Electrical Safety Standard were created. And today, we're going to break down exactly how it works.
So yeah, how do you control a hazard you can't even see? It's a fundamental challenge, isn't it? I mean, it's not like a wall you can just walk around, or some chemical you can lock up in a container. Nope. To control electrical hazards, you need a totally different way of thinking. A system, really. A deeply ingrained set of rules and principles.
And here's the answer, right from the standard itself. Its whole purpose, its reason for being, isn't just to have rules for the sake of having rules. Not at all. It's about building a solid system to stop the absolute worst from happening. We're talking asset damage, sure, but more importantly, devastating injuries and even fatalities. The stakes just couldn't be higher.
Okay, so here's how we're going to tackle this. First, we'll look at the invisible danger. Then, we'll dive into the 4 pillars of safety. After that, we'll get into the nitty-gritty rules for live power, see how it's a system built to last, and finally, we'll talk about your role in the system. Let's get started.
All right, Section 1, the invisible danger. You can't really build a defense until you know exactly what you're up against, right? So this first part is all about defining the risk. What's the scope of the problem, and who exactly does it apply to?
So, who's covered by this standard? The short answer? Absolutely everyone. The document is super clear about this. It doesn't matter if you're a full-time employee, a contractor just there for a day, or even a visitor. These rules apply to you. Think about it. Electricity doesn't care who you are, so the safety system can't either. And what exactly are we trying to prevent here? This is the official definition of electrical risk, and I want you to pay close attention to the wording. Permanent disabling injury or fatality. We're not talking about a little zap here. The entire point of this standard is to prevent those life-ending or life-altering events. It's serious stuff.
Okay, so we've defined the risk. Now, let's get into the how. How does this whole thing work? Well, you can think of this standard as being built on 4 really simple but powerful pillars. These 4 pillars are what hold the entire safety system up.
Pillar number 1 is risk. This is all about being proactive. It's the foundation. It means we don't just sit around and wait for something bad to happen. Instead, you have to actively go out and identify, evaluate, and really understand every single potential hazard before anyone even thinks about starting work. Okay, that leads us right into pillar number 2, work method. See, once you know the risks, you need a plan, right? A documented, step-by-step plan to control them. This pillar is all about creating those safe work procedures and permits that make sure every job is done the same safe way, every single time. Of course, a great plan doesn't mean much if you don't have the right gear, and that brings us to pillar number 3, equipment. This one is all about the physical stuff, the hardware. It's about making sure every tool, every cable, every piece of equipment is designed right, installed right, and regularly inspected and maintained. And finally, we have the pillar that ties everything else together. And honestly, it's the most important one, people. Because at the end of the day, a system is only as good as the people using it. This pillar makes sure that every single person working on or near this stuff is properly trained, competent, and officially authorized to do their job. It's the human element.
Okay, so we've got our 4 pillars: risk, work method, equipment, and people. Now let's see how they work in the real world, specifically in one of the highest risk situations you can imagine, working on or near live power. This is where the rubber really meets the road. First off, let's be super clear on what energized actually means. It's not as simple as the switch is on. The standard defines it as being connected to any electrical source, or even being exposed to hazardous induced or capacitive voltages. It's a really broad definition, and that's on purpose, to cast the widest possible safety net.
So you can't just, decide to go work on a live circuit. No way. There's a strict, mandatory 3-step process. First, you have to complete a formal work permit. Second, you develop a really detailed work plan. And third, you have to get that plan signed off by an authorized person. The key takeaway here is that nothing, and I mean nothing, happens until you get that formal approval.
Now, that work plan we just mentioned, it's not just some quick checklist. Look at the level of detail required. You need schematic drawings so you can actually see what you're working on. You need a step-by-step sequence of the entire job. You need a specific list of the right insulated tools and arc flash PPE. And this one is so important. You need a planned-out rescue sequence. They're literally planning for the worst-case scenario before anyone even picks up a tool.
And here's a perfect example of that people pillar in action. You never, ever work on live equipment alone. A dedicated safety observer has to be there. And get this, their only job is to watch and be ready to respond. They're not helping, they're not getting tools, they are just watching, looking for trouble, and ready to kick that rescue plan into action. They're your lifeline.
All right, so having a standard is great, but a document sitting on a shelf doesn't really do anyone any good, does it? So how do you make sure it's a living, breathing part of the culture? This next part is all about the systems in place that reinforce the standard and keep it effective.
You know, words really matter, especially in a document like this. The language is very specific for a reason. So when you see shall or must, that is not a suggestion. It's a command. It's mandatory. Should means it's highly recommended, but not compulsory. And may means it's optional. Knowing the difference is absolutely key to knowing what's expected of you.
Another cool thing is that the system is designed to have a memory. Detailed records are kept for pretty much everything: risk assessments, training records, equipment tests, audits, you name it. And this isn't just paperwork for the sake of paperwork. All this data creates a trail that lets everyone learn and improve. It ensures that lessons are actually learned, so the whole system just keeps getting safer and smarter.
And to make sure it doesn't get outdated, the entire standard gets a full top-to-bottom review every 3 years. This isn't just a quick look over. They incorporate lessons learned, new technology, and audit findings to make sure the standard keeps evolving and stays effective in the real world.
All right, that brings us to our final section, and you could argue it's the most important piece of this entire puzzle. We've talked about the risks, the 4 pillars, the rules for live power, but at the end of the day, any system is only as strong as its weakest link.
After all that complexity, after all the details, it really all boils down to this one simple, powerful line, taken straight from the standard itself. The number one responsibility for every single person is just to comply with it. That's it. You are the final crucial link in that safety chain.
And that really just leaves us with one final question to think about. We've seen this incredibly detailed system that's designed to keep you and everyone around you safe from this invisible danger. It's built on a foundation of managing risk, using the right methods, the right equipment, and having the right people. It's all there. So the only question left is, what's your part?